created by Howard Webster and published by Milton Bradley in 1974, is a beloved childhood game where your objective is to connect 4 of your discs in a row, diagonally, vertically, or horizontally, while preventing your opponent from doing the same by dropping down colorful discs down a 7x6 grid. Connect 4 can be described as a 2-player adversarial zero-sum game with perfect information for both sides, meaning one player wins, the other loses, and when that player wins, the other loses an equivalent amount, which means the total payoff for all players adds to 0, and perfect information for both sides, meaning that both players know about the game state at all times, for example, all moves made past and present. But before we discuss how to always win Connect 4, we need to solve Connect 4 first. Since its release in 1974, mathematical solutions for the game were being thought of. The game was first sold by James Dow Allen only 14 years later on October 1st, 1988, and then independently 15 days later by Victor Alice, both using knowledge-based approaches as solutions for Connect 4. Sadly, due to the complexity of Connect 4 and technology at that time, it prevented a brute force analysis of its about 4.5 trillion possible positions. Will we ever be able to strongly solve Connect 4? Turns out, yes, we can! Starting with John Trump's Connect 4 database, we were able to find a brute force approach, and later using AI algorithms like min-max and optimizations like alpha-beta pruning, we were able to strongly solve Connect 4 with these methods. We definitely do not have time to cover all these approaches, so we're just going to be focusing on the min-max algorithm. With the min-max algorithm, it tries to figure out what is the best move the player can make without knowing what move the opponent is going to make, by checking all branches of a game tree to a certain depth and seeing which branches will maximize our score and minimize the opponent's score. We can then evaluate all branches and pursue the branch with the most winning positions for us and losing positions for the opponent. Luckily for us, we know that there's a finite amount of moves possible, so we know our depth for the game tree is 42 moves. We are then able to generate a set of moves that will perfectly counter any move the opponent makes. This is called perfect play. However, as the game progresses, the time and space complexity will keep increasing, meaning that the algorithm will take longer to run, resulting in a slow performance. To combat this, we can use alpha-beta pruning, using 2 values, alpha and beta, to keep track of minimum and maximum scores that we can achieve. Alpha being the best score that we can achieve, and beta being the best score the opponent can achieve. As we explore further down the game tree's branches, if we find a branch that will not improve our current best scores, we can just skip it and move on to the next branch, so basically pruning that branch off. This reduces the number of moves we have to evaluate, getting rid of possibilities that end up in losses or draws, and focusing on the branches with moves that will result in a win for us. Now that we have discussed a possible solution to Connect 4, we can then run our algorithm and see how to play a perfect game of Connect 4. And when we do all this, it shows that it is first player win. So with perfect play, the first player will always win. So if you want to win at Connect 4 every single time, you just have to play first, play perfectly, and think 42 moves ahead. Easy enough, right?